Okay, welcome. This is the midterm review packet. Make sure you've got your reference table and a calculator close by. Number one, the diagram below represents a portion of a 100 milliliter graduated cylinder. Read the meniscus. And the meniscus is the bottom. So we'll notice the scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's right in the center, 35.0. Which set of laboratory equipment would most likely be used with a crucible? So hopefully you remember a crucible is that teeny tiny little thing with the lid. So you're going to need the clay triangle to support it. That's the clay triangle. And then in terms of tongs, we're going to need the clippy pointy nose one. So choice A. These are test tube tongs. I apologize for my cough. Number 3. What is the burette's reading? So don't forget, a burette, you go backwards. So we're getting larger as you go down, but it's still the same idea. So this is 16.1234. Looks like right on 16.4. However, since we can go beyond, it's 16.40. When the meniscus is red, what is the volume to the correct sig figs? So 70. So this is 71, 2, 3, 4, 5. This is 75. This is 76. So it's not in the 80s. Whoops. Not in the 80s. So looks like 75.5, 6, 7, something like that. So then the question is, do you need that extra decimal place? Well, I'm sure of the tens. I'm sure of the ones. So I'm going to estimate the tenths. I don't need two of those. So it is choice A. Which temperature change indicates an increase in average kinetic energy? So average kinetic energy is temperature. First of all, you need to make everybody the same temperature scale. So what I'm going to do is I'm going to add 273 to each Celsius value because that's how you convert. So this is 288. 288 to 298 is an increase, but just for the sake of example, I'm going to add 273. This is 310, so that's a decrease. This is 273, so that's a decrease, and this is 298, so that's a decrease. So that's why 5 is A. An aluminum sample is a mass of 80.1 grams and a density of 2.70. According to the data, to what number of sig figs should the calculated volume of the aluminum sample be expressed? So density equals mass over volume. We don't actually have to solve this, by the way, but this number has 3 sig figs. This number has 4 sig figs. So we're going to be multiplying and dividing here. So we need the fewest number of total sig figs, which is 3. Not 4. What unit is used to express an amount of thermal energy? That's a joule. That's on the front of the reference table, table D, which is equal to 200 degrees Celsius. I'm going to go and add 273, which, by the way, that formula is on table T, the conversion formula, and you'd get 473 Kelvin. Which quantity of heat is equal to 200 joules? So kilo, if you look on reference table C, kilo is 10 to the third, which is equal to 1,000. So 1,000 times larger. So 200 joules, if you remember dimensional analysis, 1,000 joules is in 1 kilojoule. So we're just going to divide by 1,000. 200 divided by 1,000. And you get 0.2 kilojoules. Choice C. Which mass is 4 sig figs? So remember, a number less than 1, you start at the decimal, move towards the right. So you skip that 0, that's 2 sig figs. Start here, that's 3 sig figs. Any number larger than 1, we'd start at the right and move to the left. This has 4. You don't count that 0, so this is 3. So choice C. Expressed to the correct number of sig figs, the sum of the two masses is 445.2, which produced this answer. So when you add or subtract, the final answer should have the fewest number of decimal places, and since this has 2, one of your choices needs to have 1 decimal place. These don't, and these don't, and these don't. Okay. A student collected the data below, and we're looking for density. So the formula of density, again, on table T. The volume is easy because it's right there, 25.3. But how are we going to figure out the mass of the distilled water samples? That's not here. So when it's empty, it's 141. With the water, it's 163. So it's 22 grams. If I could, yeah. So 22 divided by 25.3 is going to give me 0.869. So that rounds to 0.87. Basically, it says multiply and go to the correct sig fig. So 52.6 times 1.214 gives me 63.8564. When we round to sig figs with multiplication and division, it's to the fewest number of total sig figs. So this is 3, this is 4, so we want 3 sig figs. So 1, 2, 3. Does the 5 round an 8 up? Yes, so 63.9 is our answer. What is the density? So density is mass over volume. It says the mass is 162.2 grams, but I don't know my volume. Well, I can determine it. Volume equals length times width times height. So 6 times 3 times 2. Now, this is 2 sig figs, this is 2 sig figs, this is 2 sig figs. So my final volume is 36, not 36.0. So then when you divide, you're going to have 2 sig figs in your final answer, 4.505 repeating, but we want 2 sig figs, so it's choice C. We're looking for percent error in number 15. That's also found on table T. So basically you have to, well actually it's asking us to look. Measurements are, okay, so I need to find first the student's density, which is 25.6 over 9.1. 25.6 divided by 9.1. So that is 2.81 grams per cubic centimeter. So that is the measured value. So now to find the actual density of aluminum, I need to go to table S, and it says it's 2.70. 2.70 is the actual. So then I need to subtract 2.81 minus 2.70, which is 0.11, and we're going to divide it by the actual, which is 2.70, and then you're going to multiply it by 100. Whoops, hold on. I need to times 100. Okay, so it's 4.07%, so 4%. Another percent error. A student intended to make a salt, oh, I get this one wrong sometimes, so hold on. A student intended to make a salt solution with a concentration of 10 grams of solute per whatever, but it was actually found to have 8.9 grams. What was the percent error? So actual is 8.9. I always get, I don't like the way this is written. So 8.9, 10 minus 8.9 would be 1.1 divided by 8.9 times 100. See, yeah, I did it wrong. I always do this wrong. Yeah, the intention was, so it wants the actual to be 10. This would still be 1.1. See, I'm telling you, I would not get 100 on the regions because I thought that actually it was 8.9, so that's the actual value, when in reality, you wanted that 10 to be your actual. So 1.1 divided by 10 times 100 is 11%. See, Mitiga would not get 100. We're looking at heat formulas. So Q equals MC delta T, which is found on table T. However, since it's looking for a final temperature, we have to substitute the definition, which is T final minus T initial. So 209 equals 10 times specific heat of water is 4.18. T final, I don't know. T initial is 23. So 4.18 times 10, I don't have a lot of room here, I apologize, is 41.8 times TF minus 23 equals 209. So we're going to divide both sides by 41.8. Can barely read that. 209 divided by 41.8. And we get 5 equals T final minus 23. Add 23 to both sides, and you get 28 degrees. So I'm going to erase that now. I wish that would erase a little bit better. All right. What occurs? It's going to bother some of you. We need to have everything erased. What is going to occur when a 35-gram aluminum cube at 100 degrees Celsius is placed in 90 grams of water at 25 degrees Celsius in an insulated cup? So the water is at 25 and the cube is at 100. Well, heat flows from hot to cold. So the cube is hot, it's going to flow into the water. Heat is transferred from the aluminum to the water, and obviously the temperature of the water will increase. So that will be choice B. Which property is a measure of average kinetic energy? That's the same as temperature. Definition, we got to know. Which has the highest average kinetic energy? Well, which has the highest temperature? We don't care about the volumes. Which is equal to 120 Kelvin? So 120 Kelvin minus 273 is negative 153 degrees Celsius. So once again, use the reference tables. Exothermic means giving off of heat. When you boil water, that's a liquid going to a gas, and I need to add heat to it, put it on the stove, so that's not it. When I melt copper, that's a solid going to a liquid, which means I need to take heat in. Condensation of ethanol vapor is when a gas becomes condensation liquid. That's my answer. And sublimation is solids straight to the gas phase, which we haven't talked about too much yet. Q equals MC delta T. Again, we're looking for mass. So 418 equals M, I don't know, it's water. So this specific heat capacity is found on table B. And T final minus T initial, this is 10. So once again, we have 41.8 times M. So 418 divided by 41.8, and you get 10 grams. Which is a mixture? Aqueous, because that means dissolved in water. Everything else is pure throughout. Bronze contains 90 to 95% copper, 5 to 10% tin. Because these percentages can vary, bronze is classified as a mixture. If it was a compound or an element, it would be considered a pure substance, and substances have definite formulas. Mixtures can vary. A mixture of sand and table salt. Oh, hold on. No, I don't want to look at that. It can be separated by filtration because they differ in. Okay, so I don't know the boiling point of these. That's not it. Densities, sure, I guess they would have different densities, but that's not how they can be filtered out. Think about what a filter does. Filters keep big things out. And so sand will stay in the filter, but table salt can go through the filter as long as you dissolve it in water. So you got to do that. At room temperature, sand and water can be separated by, once again, filtration. The water will pass through the filter, but the sand will not. What will pass through the filter paper? Water, sand, and salt. So passing through, the water will definitely go through. The sand will not go through because that's too big. But would the salt go through? Well, the salt will go through because it's dissolved. If there was no water, it wouldn't go through. But allowing the water to be part of it allows the salt to dissolve. Equal amounts of ethanol and water are mixed. Which process is used to separate ethanol? Whoa. From. Look at that misspelling. That's weird. So that is called distillation. That's a straight up definition. Distillation is separation of a mixture of two liquids based on boiling point. Petroleum can be separated by distillation because the hydrocarbons in petroleum, so hydrocarbons, do they have elements with identical? Well, first of all, they would have to have different boiling points, okay? Because otherwise, it wouldn't make any sense. But hydrocarbons is some C's and H's. That is a compound. Excuse me. Which sample can be separated into different substances by physical means? Once again, physical separation is in a mixture. Okay, now we're talking about atoms. The historical development of the atoms. The first is atomos, hard indivisible spheres. So D must come first. Then what comes next? Atoms have small negatively charged particles, the electrons. Yeah, both of them. And then what comes after that? Is it small dense nucleus or wave-like properties? It is small dense nucleus. That is Ernest Rutherford, who I believe would be the Regents' favorite. Which particle has a mass that is approximately equal to the mass of a proton? So I'm going to reference table O. And the mass of a proton, it says 1 over 1p. So the mass is 1. So looking on table O, I want to find somebody else with that same mass. Alpha particle has a mass of 4. Beta particle has a mass of 0. Neutron has a mass of 1. That's probably our answer. Positron is 0 over 1. So use table O on that one. Which statement describes the charge of an electron and the charge of a proton? So they have different charges. Electrons are negative and protons are positive. But they are both 1s. So it's choice D. Both worth 1. Okay. Compared to the charge of a proton, the charge of an electron. We just answered this in a different way. So they have the same magnitude, meaning they're both 1s. But the difference is the sign. What is the overall charge of an ion that has 12 protons, 10 electrons, 14 neutrons? Well, first of all, neutrons are neutral, which means they don't have any charge. So plus 12 minus 10 gives me overall plus 2. I need some coffee here. Which conclusion was a direct result of gold foil? An atom is mostly empty space with a dense positively charged nucleus. Yes. Don't even give all that other stuff a second thought. Which substance at STP can be represented by this particle diagram? Notice how they're all clumped together nice and tightly. So I'm asking you to look at, phase of matter at STP. Nitrogen's a gas. That's a gas. This is a solid. This is a gas. Gases would fill up the container with particles all the way around. These are clumped together. That means it's a solid. An excited state of gallium. So if I look for gallium, it says on periodic table 2, 8, 18, 3. Oh, that's my answer. False, because this is ground state. So this has 31 electrons in this order. We still want 31 electrons, but we just want a shift. So maybe somebody from here jumps here. Or maybe somebody from here jumps up here. So we can't have more or less than 31. We need to have the same number of 31, just a different shift. So this choice A wouldn't work because it's fewer than 31. Choice B would work because, look, 1 from 18 went up. So that's this. This adds up to more than 31. So choice B. The total number of protons, electrons, and neutrons are shown, which are isotopes of the same element. So isotopes have the same number of protons, different number of neutrons. So A and D could be A and Z could not, different, I'm looking at the wrong thing. Oh no, A and Z do have different number of protons. X and D don't have the same, X and Z do not. So let's look, A and D have the same protons, but different number of neutrons. That is the answer. 41 isotopes of the same element, so you'd need the same bottom number and different top number, which is A. Which is the total number of neutrons in oxygen 18. See how it says dash 18? That means it's the mass. Oxygen, being oxygen, will always have 8 electrons. Sorry, 8 protons. So 8 protons, but it's asking for neutrons, so we subtract. So the difference is 10. So again, this is an isotope, which is a little bit different than the one you would look on periodic table and find. Okay, atomic mass is that. It represents the total mass? No, it's a weighted average of the most abundant or the naturally occurring. Nope, naturally occurring. And again, that formula is not on the reference table, unfortunately. A 100-gram sample of naturally occurring boron contains blah, 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 blah. Okay, what is the atomic mass of naturally occurring boron? Okay, so we take 10.01 and it is 19. So out of a 100-gram sample, this would be 19.78%. So they're going to want to do this. And then this is 11.01, and then we're going to do this. You could also have done this. Hold on a second. And then divided by 100, but you see that's not a choice here. So you'd have to make the top choice, which is choice A. Making these 100-gram sample, assuming it's a percent. That's nasty. I don't like that question. Energy of the electrons. So if you're at a concert and you're front row, you can see everything, you can hear everything. If you're in the back row, you're straining to see, you're straining to hear, somebody's in the way, you're putting in a lot of energy to take that in. So the further out is the more energy. First shell has more energy than the second. First shell has the same energy. No. Third shell has more energy than the second. Yes. Which, when we're coming back down, all that extra energy is given off. So emitted means given off. Electrons should not change. It's just the energy of them. Okay, bright line spectrum. I sometimes get this wrong. Which are present in the mixture. So I just bring it up. So, and of course, like you can see how like scraggly my lines are. So I don't believe G is in here because see how these guys did not come down? Yeah, that didn't come down. So D and E alone, which is choice A, which is right. Good. I got it right. Took me a minute. The electron configuration for potassium in the excited state. So first of all, let's find potassium in the ground state. 2A1, that's 19 electrons. So this is ground. I don't want that. I want the same number of electrons just shifted around. So part A, it's not the answer because it's fewer than 19. Oh, but part B, somebody from the third shell jumped to the fourth. That's my answer. A specific amount of energy is emitted when excited electrons return to ground. This emitted energy can be used to determine the identity. This is the bright line spectrum, which is an identity thing. It's produced as electrons, not proton, are moving from the higher to the lower. We're giving off the extra energy that was gained through heating. In the wave mechanical model, an orbital is defined as, circular paths, those are Bohr, the region of most probable location for electrons. And as far as the regions goes, that's all you need to know. The arrangement of elements from left to right on period 4 is based on atomic number. It used to be atomic mass, but actually they probably chose period 4 because then there are a few discrepancies. Which consists of a metal, a metalloid, and a nonmetal. So again, here's my very quick periodic table. Got this zigzag situation over here. This is H. So most of the periodic table are metals, except for these are nonmetals, and along the and this hydrogen is also nonmetal. These are the metalloids or semi-metals. So I'll keep pink. Lithium's a metal, sodium's a metal, game over. Chromium's a metal, tungsten's a metal, game over. Tin is a metal, carbon is a non-metal, silicon is along the zigzag. That's my answer. 2 non-metals. Most similar chemical properties are in the same vertical column. Those are called groups. So I want elements that are in the same vertical group, not horizontal. That's wrong. We want up and down. So bromine, gallium, mercury, those, no, they're not even all in the same row. Chromium, number 24, lead, number 82, and yeah, this is garbage. Nope. Oxygen, sulfur, and selenium, these all go down the same group. That's right. NOF go across. That's why that's not it. Compared to the atoms of nonmetals in period 3, the atoms of metals in period 3, nonmetals versus metals. So we're all in the same period, which means they all have the same number of shells. If you look, it's always 2-8- something. So metals have fewer valence electrons. We're talking 1s and 2s versus 4, 5s, or 5, 6, 7s, and 8s for the nonmetals. Okay. 56. You guys hate these. So we're trying to figure out where X would be. So crisscross your charges back up. So, or your subscripts back up. This is a -2. This is a +3. So you want somebody with a +3 charge. Barium is in group 2 with a +2 charge, so that's not it. Cadmium, where are you? Looking for CD. I can't find that right now. Let's skip it. Indium is in group 13. Group 13, yeah, that's it. I gotta find cadmium though. Sodium's group 1. Cadmium, where are you? Oh, it's number 48. It's a +2. That's not it. Which property can be defined as the ability to be hammered into thin sheets? That's called malleability. At STP, which is a good conductor of electricity, we want metals. So who's the metal? It's silver. 59, once again, crisscross your subscript back up to make it your charge. So who would be +2? Well, it would be in group 2. But is group 2 a metal or is group 2 a non-metal? Group 2 is metal. Finally, this is our halfway point. Graphite and diamond are 2 solid forms of carbon. Why are they different? Well, they have different structures. Diamond is an interconnected network, whereas graphite is in thin sheets which can easily break. I'm going to take a break. So for the second half, find my second video. Thank you.